Yeah, hi. Good evening, everyone.
Good evening,
Good
sir.
evening, sir.
Good evening, sir.
Good evening. Okay.
Good evening, sir.
Good
Yes.
evening, sir.
Good evening. Okay. So today agenda is to discuss the week one practice assignments. So we have this in first week and second week we have only the theory assignments, not no programming assignments. But yeah, some questions have that algorithm type of flavor. So we will discuss the practice assignment before starting the session. If you have any doubt, any query, you can ask. Then we will discuss the things. Okay. You can raise the hand if you have any query. One second. Yeah, Deepu.
Sir, what is the difference between mixed memory or general memory?
Mixed memory and general memory. Where this content, this topic is discussed?
Sir, in lecture 3, sir. I think in lecture 3 or 2, sir.
Okay, let me open and share. One second. Okay. Mixed memory basically where the all type data and instructions all actually is stored. That is the context of the professor, which he's mentioned that. General memory, I'm not sure which you are talking about. Can you just stop me?
Sir, sir, just go above. I see. Just, yes, sir, yes. Please stop, sir. Here, here.
Uh-huh. Okay, generalized memory, not general memory.
Sorry,
Okay,
sir.
and
That's.
where is the mixed memory you are talking about?
Sir, both are in same place. They compare both them. After general memory, they giving detailing about mixed memory.
Okay, one second. So basically, memory is the term where we store the data. Okay, so each system have different types of memory. So that type of memory is defined based on the that connections, how much close actually they are actually assembled to the processor. So how much they are passed to the communication. So if we talk about the memory, so memory means just store the data related to the that programs what we are executing on the computer system. But this computer system is not store only the data. Data means here on what data we are performing some task. Okay, so that data may be anything. It may be integers value, it may be strings, or it may be float value. That type of data we can see that. But another things are so we also provide the instruction set to the computer. So what actually how the computer actually perform the task, it takes the sequence of instruction one by one, and it execute the instruction. But for instruction what data is required, so that data is called by the processor from the memory, and that data is also fetched. So in memory what happens, so generalized memory, it is given this is here you can see data. Okay, so what type of data we have? We have like A type, B type, operational. This is some different type of data. So here data is categorized. So what relevant data we have? So we if we are performing some operations or some tasks, so task related instructions, task related data, and some other data which we manage to just store the that position of the executions. Like some we also that our compiler also maintains some that stack position. So where our actually control flow execution happening, what point actually execution is happening. So other things are also stored that is required for the execution. So that also store the memory. So sometimes what happen, we categorize the memory. So that memory is same, but we categorize the space area for the different purpose. So because of that, we generally we can say that this is a mixed memory. So mixed memory means that contain the different types of data in the different positions. Okay, so when we will learn this that C programming, so when we will learn the function, okay, so in the week 5 context, so So you will see that in when we write, when our program is executed, so what type of memory actually is used for some specific purpose in the program. So some we called as a stack memory, some we called as a heap memory. So these all type of memory categorization is actually exist in the different place of the memory. So suppose the address, first address of the memory is 0, and last address of the memory is like 10,000. So what we can do, we can categorize the memory that 0 to 1000 we will use only for the that instructions. Okay, after 1000 to 2000 we will use that partition only for the data that required for the that program. And another part, similarly we can categorize in the different purpose in the memory place. So that we are just dividing the partition of the memory, and that partition is used for the different purpose of different type of data storing. So that is just the main purpose to discuss here. And the in the another terms, we have different types of memory, like that RAM. If you have listened, these are the very common name about the memory: RAM memory, random access memory, and ROM memory. We have that secondary memory. Okay, and we have this registers. Okay, registers, and we have cache memory. So all these are also different types of memory where the purpose is different for each type of memory. So that registers are very close to the processor, and processor store the temporary data during the that computation. Okay, so suppose if that our processor is executing some addition operation between two variable, so that will store that data of two variable in some place close to the processor. So that place is actually called as a registers, and that registers have some very small amount of space. Okay, so that only store the data which is only required for the computation on the temporary at that point. Okay, so after registers, so that actually that data, if data is not further used, so that data will be passed to the RAM memory. So RAM is also a memory which is we called as a volatile memory. If we turn off the power, that data will be lost. So that if you purchase any phone or computer, you always focus that that RAM is comes under the features when you purchase any phone, that how much memory you have in the phone. So there are two types of memory, that is one RAM and another is ROM. So RAM is just a volatile memory which is used to store the data related to the program which is currently executing. Okay, suppose we are running a application, or suppose we are running a video in our computer device. So that data related to that video, as well as the required instructions which are running the video on our system, that data will only come into the RAM from the permanent memory. So permanent memory, we have the secondary memory where the data is always exist without any power loss. So we can see that that memory is the non-volatile memory. If we will turn off the power, that data will still remain in that memory. Okay, so our all data actually stored in the permanent memory, but when we run any application, when we run any task, so the related data comes under the RAM memory from the permanent memory. And that processor communicate that data from the RAM memory directly. So what data is required in the instructions, so that data will be fetched from the RAM memory, and output will be returned to the RAM memory. Okay, so in this way communication has happened with the that processor and the memory. So that I think that structure is also given in the that split type of data structure. You can see this example is given. So here this circle part is actually a CPU, central processing unit, and this is not, this is a processor actually. And we have this yellow part which is highlighted, that is registers. Okay, so that contain the that are temporary memory that stores the data which is required for the instruction execution, or for the temporary. Okay, so that all combination, we have another component also within with this CPU, that processor and registers. So we have control unit also. So all this combination of these component called as a central processing unit. And these that CPU and registers communication happen from the that large memory which is called as a RAM, random access memory. And uh, the main data comes into the RAM from the secondary memory. So all data we stored inside the secondary memory. So when we will execute any function, so the related data will come there. this RAM memory. And in that particular task, what instruction is executing, so that data will be come into the CPU and will for the execution. So this is the complete cycle of the execution, how the data is communicated. So these are the memory things. Okay, so yeah, any query right now for the memory things?
Sir, RAM and ROM both are they are memory or not, sir?
Yeah, both are memory. Both are the type of memory.
Sir, if I have installing some applications such as some apps, the first storage goes to RAM and then goes to uh,
No, installing application means you are suppose if you are installing any application, so that application will be stored in the permanent that memory. Okay, so the related data, all instruction, all will be stored in the permanent memory. But when we you will run that applications, so required data will be fetched from the main that permanent memory to the that RAM, random access memory. We also called as a main memory. Okay, so that data, so if you purchase any phone, you always see that that RAM is like 4 GB, 8 GB, or ROM is like 464 to 128 GB. So that 168 one, that 64 GB is the permanent memory. But what application is running, required data will come into the RAM. Okay, so that you have the 4 GB or 8 GB, so that required execution data will come into the RAM first. After that, your processor will communicate to the RAM memory directly for the execution.
Okay, sir.
Okay.
Sir, in CPU, sir, there are two parts that is register and ALU. They both are combined, and we can say that is the CPU, sir. So,
Yes, yes, so not only the two part, we have more part also. So let me share this diagram. Yeah, so you can see in this is also a the diagram of that computer device. We can say that. So here, this complete yellow part. Okay, so this complete yellow part, we can see that this is the CPU, where the control unit is also there. Okay, we have this part is now a processor that contain the registers and that combinational logical unit, arithmetic and logic, ALU. So we generally call it as a ALU, arithmetic and logical units. So that is actually the main thing, so that perform this arithmetic and logical operations. Okay, so data is stored for the instruction, what instruction is executing by the processor, so related data will come inside the register. So this is not the single register, so there are multiple registers actually that CPU have. So data will be stored temporary for some time for the registers, and when the data will be used, it will come back to the main memory. Okay, so control unit is basically manage all the things, that communications, all communication, what data is fetching from the main memory. So all instructions and data. Okay, so all instruction and data will be stored first inside the main memory. So now what instruction will execute? So that instruction will be fetched from the main memory and will come to the registers. And that instruction require what type of data, that data will also be fetched from the main memory and come to the main that registers. After that, this CPU, that ALU unit, actually will get this data and will perform the operation. Okay, so like for example, if you are performing some sum operation, so s equal to a plus b, that we have this. Okay, so now we have this data like 5 plus we are passing some data 5 plus 10, and we want to store the result to the s variable. Suppose this is the instruction. Okay, so s equal to 5 plus 10. So to for this instruction is executing by the processor. So this operation, first thing, this is the is one instruction. So this is not the exact instruction we pass as the CPU. There are some assembly language. So in C, actually, what we write as a high level programming language. So C called as a high level or medium level programming language. So we write this instruction in the normal English language, but that actually convert into the another form. That convert into the assembly language. After that, that convert into the machine language. Okay, so machine language instruction actually pass. So corresponding machine level instruction for this line will be passed to the from the main memory to registers, and it will store into the one registers and related data. So this 5 and 10, what data is required for this operation, so that data will also be fetched from the main memory and will come into the another registers. Okay, now this combinational logic, that ALU, arithmetic and logical unit, will get this data 5 and 10 and will perform the addition operation and will return the solution in another registers. Okay, and now that data will come back to the main memory. Okay, so this is basic communication channel. In between, sometimes we also use one cache memory. Okay, so that CPU and in between registers and main memory. So here in this diagram, what we are seeing, that we can directly, so communication is happening between registers and main memory directly. Okay, by the control unit. So control unit is actually handling all these things. But we also use a cache memory. Sometimes cache memory comes under the CPU or sometimes not. So that cache memory, what is the purpose of cache memory is, cache memory store the data which is actually frequently coming in the that processor. Okay, from the main memory. Suppose any data which is actually repeatedly coming again and again to the processor. So CPU, what CPU that cache memory will do, cache memory will store that data for some specific time. So in between main memory or register, so we can add one more type of memory, cache memory. So those data who are again and again coming into the processor, so that data will store for some time in this cache memory in between. So for next time, if this data is required again, so that communication will only be happen between registers and cache memory. Okay, that will not be fetched from the main memory, because that we will check that if this data is available in the cache memory. If not, then we will check with the main memory. If it is already available, then that data will directly fetch from the cache memory. So it will actually reduce the communication time. Okay, so this is the purpose for the cache memory generally. Yes.
Okay,
So,
yes, thanks.
what is the size of the cache memory?
That is depends on the that manufacturer, what size is. Generally this is in MB, not too much.
Sir,
Sir,
sir, what is assembly language?
Yeah, assembly language is one intermediate language. So what is first is high level language. Okay, so high level language we have, this is more human actually understandable language. Okay, after that we have the compiler. So compiler, those who runs this program, what we are writing in the C, what we are writing in the C++, Java, in between we have the compiler things. So compiler convert this high level language to the assembly level language. So assembly level language is more closer to the machine. So that convert each instruction in more details, step by step. So how the all operation will be performed, and that is also readable, but that is not easy to understand compared to the that C, that high level language like C.
हुआ करेगा
Okay, but after that assembly
आ
language,
देख करिए हम
that
बहुत है
language will be converted into the machine
हम कहा
language.
देखें पूरा होगा देख
Language
करोगे
means 0101 like this type, because computer only understand this
पढ़ा तो
binary
लगा होगा
numbers
उसका
0101.
दे
Okay,
दूंगा मैं
that
पहले लगा
instruction will be executed by the processor CPU. This is the
sir,
this is totally compilation process. Yes.
sir, I want to know what is the difference between a EPROM and a ROM, sir.
So this is the type of ROM actually. So EPROM, that means erasable programming, that memory. So they can be erased actually by some process. Okay, so ROM means read only memory, and that are permanent. That cannot be changed. The data cannot be updated. But some ROM is also available that can be erased or updated by some specific process.
Okay, sir, got it.
Okay, so that is
Sir,
just generally
sir,
type of
can you send,
hmm.
sir, can you send this supplement in group search or supplement section? This
What you're saying
PDF, sir.
supplementary. So this is available now in the supplementary content. You can see supplementary
Sir,
content, week-wise notes.
no, sir. You are showing that memory hierarchy
So
PPT.
yeah. So this PPT which I'm showing, this is the lecture PPT. This one. Okay, this is the
Yes, sir.
lecture PPT, and this is the week-wise notes. So both are available in the supplementary content. So lecture PPTs are available here. Okay. And week wise summary notes is available inside this link. You can click on this link. Okay.
Okay, okay,
Now
fine.
you
Sir,
when you click on this, you will get all the weeks, all 10
Okay,
weeks. You can see all this PDF.
sir,
Yes.
So in the loop section, how does the program counter work?
How the program counter works. So program counter is just a registers, okay, that contains some value, and it value is
Yeah.
update actually after some process. So what we can say that if we are taking some program counter, like that is just simply a register. So like r suppose r0, I am giving the name. Initially we set as a zero value for this. Now this program counter, if you are using this as a program counter, you can make any register as a that counter, and we are performing some task. So after that we will check this register's value. If this register value is not satisfying some condition, suppose we are taking some conditional statement or conditional thing. Suppose we are checking if r0 is less than 10. So what we will do, we will perform the jump process, jump to set instruction 1, like instruction 1. So that means your control will be moved to the step 1, and again process will be start again, and in between we will update this variable. Okay, suppose is this step number 2 is incrementing this r0 equal to r0 plus 1. Okay, so now in the each iteration we are updating this variable, so that we have started with 0, but each iteration we are updating by incrementing by 1. So and after that we are checking one condition, and based on that we are just deciding the control flow. So r0 is initially was 0, so after that we have updated to 1. Now 1 is less than 10. Yes, now we have jumped back, and again it will increment it 1 again, so it will become 2. So in this way we can control the how many times we want to iterate the things. Okay, so that is called as a loop. Okay, and after
Okay, sir.
that when the r0 reached at the 10, so at that time this condition will become false, and this instruction will perform, and we will jump to the next part. So that is the termination of the
Okay,
loop.
sir. Fine.
Yes. Yeah, Shivam. Yeah, Shivam Sahu.
sir, I have problem to understand the concept of sum of n number.
Sum of n number.
Yes, sir, in a communication lecture.
Okay, okay. So let me open that slide to understand. Okay, this is I think at the end. Can you tell me the slide number if you have opened?
Sir, in last lecture,
Yeah, yeah.
Yes.
It's after the
I mean,
quadratic
like,
equation exam.
sir, above it. Yes, sir.
Scroll up.
This one. Step toward computation. Okay.
This
Sum
one,
of
sir.
n number. This one. Okay.
yeah.
So yeah, this is the one problem. Okay, and now we have the memory model. So we have this memory model where we have this memory position, so m0, m1, m2, like this. Okay, now we have these registers. So these are the registers we are saying that which actually processor used inside the CPU, and this is the memory we have, main memory. So to find out the sum of n numbers, so suppose we have n, maybe anything, so n maybe 10, n maybe 20, so anything. Okay, so we are writing a sequence of steps, so that will actually compute the correct solution for this. So how we are computing this, you can see we are also using some control flow that statements here, that is the conditional statement. So what we are doing is initially we are taking one registers r0 and initializing with 0 value. Okay, and then we are taking another registers that is also initialized with 0. So here we will use one registers for the counter as a counter, and another register we will use as a over final result. Okay, so because we want to calculate the sum of n numbers, so n may be suppose equal to 5. So how you can calculate the sum of first five number? Okay, so here, okay, hmm, sum of n number. Okay, 1 second. Yeah, oh, this is not the first n number. This is, I think, memory. Okay. Hmm. Okay. Yeah, this is not the first five n number. This is a n any random number which is stored inside the memory blocks. Okay. So m0 to mn minus 1. So all our n number are stored in this place. In this place. Okay. Now this R0, R1, one register we will use for the final result, and one register we will use as a index. So you can see this what value we are taking inside the that square bracket, that we will use inside this register's value, directly put here, and we will increment this value one by one. So we will fetch the data from each memory location. So m0 contains the first number, m1 contains the second number. Okay, in this way we have the all n numbers. Now we want to find out the sum of uh, all numbers. So what we will do? So what we will do? We will take result, any variable result, and we will fetch the data from the first. Initially, what we can do? We can set 0 r equal to 0. After that, we will fetch the value from the first memory location. Okay, and we'll add into this m0. Okay, now this is the first addition. Now after this operation we will fetch the second memory location and will add into the previous sum, so that is m1, and then we will fetch again, so that is m2. So this is our purpose here, how we want to calculate this type of equation. Okay, because we don't know what is the value of n, we cannot write a fixed code. We have to run a loop based on the input value n. Okay, so n may be 5, n may be 10. So based on that we have to write an instruction in this way, so that instruction will read all the n number from the memory and will add. So how we can write this? So here we are taking that R1 register we are taking as a result to store the result, like similar to this R. But R0, this is we are taking just as a pointer. Okay, this will point to the memory location. So initially this is set to 0. That means this is pointing to this 0 memory location. Okay, initially we have started with this 0. Now you can see R2 equal to, okay, so R2 value we have directly assigned. So this is simply a assign operation. So we will read M, and inside this we have this R0. So what is the value of R0 right now? 0. So that will replace by 0. 0. Okay. So M0 is pointing to first memory location. So that means R2 will become a, suppose we can take example also. Suppose M0 contain 1, then 2, this 3, 4, like this. Okay. So the value of M0 will come inside the, not this is 1, will inside the R2. After that you can see we are now incrementing the counter value. We are just finding out the sum, total sum, previous sum. Okay, so R1 was set to 0. Now R1 equal to R1 plus R2. So this R2 register's value will be add into the previous R1 sum. Okay, so previous was 0 and this was now 1, R2. So you got the 0 plus 1. That means we have taken the first pointer. After that, we have incremented this value R0 to by 1. So initially it was 0, now it will become a 1. So that means we have, now we will point it out to second memory location. So now you can see this is the condition. R0. So that which register we are using as a counter, or that which is actually we are handling the total number of iteration. So that we will use inside the conditional statement. Now if R0 is less than equal to n, if this condition is true, then we will go to step 3. So our control will move to the step number 3. Okay, and your execution will start from again from this position. Okay, so in this way again you will read a that now this R0 now have updated. R0 have updated here, so to 1. So now this will become a M1. Okay, now M1 value will come into the R2, and that R2 value will be add into the previous R1 sum. Okay, so now this equation will become like a R1 equal to previous value, initial value was 0. Now we have added r1 in the first iteration, so that is now 1. Now in the second iteration it will become a m1, so m1 is pointing to 2 value, so that 2 will add into this. Now this will update one more time, so r0 will become a now 2. Okay, and now 2 is less than n. So n, initially we have any number, maybe suppose 10, if we are taking. So if 2 is less than 10, yes, again go to step 3, then start execution again. So now it will read the m2 value, so m2 is now contain the 3 value, suppose. So this will read 3. So in this way you will read all memory positions one till n position, n minus 1 position, and you are adding all these to the previous sum, and you will get a result into the r1 total sum of the n numbers. And finally, once this our r value will reached at the n value, it will, this condition will become a false. Then if this become a false, so this we will not go to step number 3, we will jump to the next instruction. So this is the final instruction. So what is the final value in register r1 that will store into the mn location? So mn location is just a this one, mn location. Okay, so that result we will store inside the memory. So this is like a computation behavior. This is, we can say that this is a main memory. Okay, and these are the registers, and this is the sequence, this is the algorithm actually. This instruction set we have passed to the CPU. One by one our CPU will execute these instructions in this according to this control flow, and finally we will get a total sum of n number in the this memory location in the main memory. Okay, so just steps are given, just run each steps, just compute each steps and see what update are happened in the each registers memory. Okay, and compute the steps in top to down manner one by one. If anywhere control statement is there, so accordingly jump back. If condition is true, jump back to the step instruction 3, and again start execution from that position top to down, like this. Okay, so in this way just compute each instruction and check what update you are getting in the registers value. That is the that is the final result you will get in this manner.
Yeah. Thank you, sir.
Okay,
Yeah.
so this here actually we are not solving this, we are thinking that how computer is solving this. Computer is just a machine. We have to pass the set of instruction, computer will just only execute in the same behavior one by one. Okay, what sequence we are passing, that computer will perform the same sequence. Okay. Yeah, next Shivam sir.
Sir, sir, can you do take example of that type of question and then show it how can I solve it?
Okay, so that we will take from
Yes, sir.
the
It's very
practice
confusing.
assignment. Yeah, that we will take.
Eighth question is there.
We will take from the practice assignment, and okay, we will solve this. Yeah, Rohan, you have any query?
Yes, sir. Sir, generally, the key components that a CPU has is the control unit, ALU, and registers, right?
Yes,
But
yes.
in the sir, but like in the lecture, professor mentioned that not just that we have more components apart from these. So can you please tell us like what are those components that are also there apart from this in a CPU?
So in generally main component as we have discussed this that control unit purpose. So you have to check the overall computer structure then.
Okay, sir.
The course here, our course purpose is not to learn the computer system.
Yeah,
Okay,
yeah, yeah.
here our course purpose is C programming. We are just giving the basic idea of the computer, how the what are the main unit of the computer, how the computation happen only. Okay, if
Okay,
you
sir.
want to learn the this computer system in the deep, then totally computer architecture course is there. Okay, then you have to go into the deep each component, registers, flip flops, these things, electronics things. You have to understand this all.
Okay,
Okay,
sir.
how these are designed. So do not go into the deep right now, but yeah, later you can explore in the details. So you just so you have to also suppose professor have explained little bit about the OS operating system. Okay,
Yes, sir.
so but operating system is very deep course. You
Yeah.
cannot learn in any one lecture or in one slides like this. Okay, so
Yes, sir.
that professor have just discussed what is the purpose of operating system, what are the role of the operating system, but how that operations are performed, if you want to know this, that you have to go to into the deep in the that course.
Okay, sir.
Okay,
Okay, thank you, sir.
so right now just understand that what are the basic purpose of these main component. Okay, after that we definitely from week 3 onward programming will start in this course.
Okay, sir.
Yeah, Prem Sahu. Sorry,
Sir,
Prem
am
Sahu.
I audible?
Yes, yes.
Sir, then what's the difference between load and assignment?
Load and
Assigning like equals to an arrow.
so load is when we fetch any data from the memory. Okay, so we are loading the data from memory. Assigning is just you can directly assign any numerical value at the suppose in the register place here you can see this r0 equal to 0. This is simple assignment operation. We are not fetching any data, we are just putting the 0 as a initialization. But here in the next line r2 where the arrow is given, okay, so here the operation is performed, load operation. Here the some operation will perform that will fetch the data from memory location m, that r0 that position, and will that data will come and assign to r2. Okay, so that load actually contain the both operation fetching as well as the assigning. Assigning simply just a store of the right side value will be assigned to the left side value. This is simply straightforward. And store operation we have, we will store the data from registers to the memory. That is called as a store operation. Okay,
Okay. Thank
reading
you,
the
sir.
data from memory, that is load operation. Right, that writing the data into the memory, that is actually store operation.
Okay. Thank you, sir.
Okay, yes, Shivam Sahu.
Yes, sir. Actually, I want to say that you can tell me
Similar
some.
type of question.
Uh,
Okay.
yeah, yeah.
Okay, okay. Yeah, Govinda. Govinda, you have raised the hand. You turn on the mic first if you are speaking. Yeah, Guru
Yes,
Sevak.
yes. Hello,
Yeah,
sir.
Govinda, go ahead. Yes, yeah, Govinda.
Sir, tell more about something about the loop, sir, and the condition and the branches and the loop
So,
counter, sir.
that we will discuss in the questions also. Otherwise, this loop and conditional statement will come in the week 3, not week 3, week 4, in the detail in the programming concept. But yeah, we will discuss in the that some assignment question. Yeah.
Okay, okay, sir.
Uh, yeah, Guru. One second. Yeah, Guru Sevak.
Hey,
Hmm.
so I have a question about the quadratic formula.
Mm-hmm.
Previous example of this one. I
Okay.
want to know like when we computing the 4AC in the discriminant of quadratic formula, do we need to do AC first and then multiply it by 4, or
You
can
can
we
do. You
just
can do. So anything. This is as we said yesterday also. So any problem can be solved in different logic, different sequence of steps. Okay. So here, what professor have written is a one way to solve this problem. You can also write a different way to solve the same problem.
okay? So I can do that in just one step, right?
So you can do, but yeah, that what condition are given in the question or statement, that just follow them. Okay.
Okay,
So here you maybe that some steps you can be just change the order. You can change the order of some steps, or maybe you can find the totally different logic also. So that all are possible. Just confirm that in each of the possible case, your sequence of steps will give the correct output. Just
okay,
ensure
thank you.
that. Okay. Then
And
your
also
logic is correct.
one more question: is equal to a logical operator, or
Yeah,
it's just an
equal to
expression?
is the compare operator. We can say that we are comparing something.
Okay,
Okay.
thanks.
Okay, and yes, Sarthak.
Sir, I had a question regarding C programming. Sir, is it possible to find cube root using C programming?
Hmm.
Uh,
So cube root, yes, there are some math library we have actually. Okay, library means if any mathematical for function like log value, tan value, all these math things. Actually, these programming language also provide some predefined functions that is predefined and built-in library that is available in the your C package. So you can directly include that package in your program by just including some statement, and after that call the function and you can calculate. Okay, so no need to write the complete program for that. So this type of math equation, math function, so there are libraries are available like square root and that power, that square power, all these things you can directly use them.
okay, sir, thank you.
That we will discuss in the when the programming will start. Okay. Okay, so I'm opening the assignment questions. Let's discuss one by one, and in that questions we will discuss that.
Sir, I have a doubt, sir.
Ha. Just yeah, Ritu.
Sir, sir,
Mm-hmm.
sir, when memory size is increased, why we connect it to the it register, then connect it to ALU? Why we can't directly connect to memory to ALU, sir?
So that actually will reduce the computational capacity, or we can say that efficiency. Okay, so that actually that if you directly communicate to the main memory, that will reduce the computation speed.
It's take long time, sir.
Hmm. Okay, so because of that,
Okay,
what is
sir.
required by the processor, that part only will be come into the that registers, and that will execute only in this way. And
Hello, sir.
these memory have also 8 different types of that materials used inside that. So that secondary memory, if suppose you can see, if you purchase any ram for your computer, that 4 GB or 8 GB, that cost will be maybe 2000, 3000, and the same price maybe you will get a that hard disk in the for the like 64 or 80 or maybe 500, 512 GB like this. Okay, so that quality is also different, that speed is also different. Okay, so that is faster, that random access memory is more faster compared to the your secondary memory hard disk, or in the history time actually that or this type of memory generally used. Right now we use the SSD, that is more faster than the hard disk, but this RAM and registers are very faster compared to the normal memory, that secondary memory. So because of
Sir,
that we
but
used
it
this.
will take,
Mhm.
sir, I am saying, but sir, it will take more time. First, we communicate with the memory, then we communicate with register, then we communicate with ALU. Sir, then when we directly connect it, it will reduce the our time of data sharing between the ALU and the memory.
So as I said that na, this random access memory is less faster compared to the registers. Okay,
Okay, sir. Okay.
so that will take more time if you directly communicating to the main memory. So that overall execution speed will be reduced, because how much speed you are thinking for the processor. This is too much fast. So that execute approx that gigahertz like that. If you see the speed of the processor is like 2 gigahertz. So that is actually too much fast. So that means gigahertz 10 to the power 12, I think something. So that number of instruction execute in the 1 second. Okay, so we need the data, so that actually is more closer to the processor. So in this speed they can directly fetch the data in the same speed manner. Okay, if you will directly communicate to the main memory, so that communication time will be increased in the and the that instruction execution time will be reduced. So that data actually what instruction will execute next, that actually will be fetched at the priorly, not at the same time. What instruction is currently fetching at the same time, we will not ask the data for the main memory. Okay, so that suppose the line number. So let me say, suppose we have two instruction. So line number one we have, line number two we have. Okay. Suppose line number one is executing by the processor currently. So the we will also get the data for the second instruction, uh, which is executing right now. But second data will also be ready in the registers for the next instruction execution. Okay. So data we will not directly fetch through the main memory, so that will actually reduce the time. So we will fetch the data priorly with before completing the previous instructions. So that is stored inside the instruction registers or data registers. Okay. Yes, Sarthak, Govinda, yeah, Akhlaq Ahmed.
Yes, sir. Hello.
Yes, yes.
Sir, what's the difference between loop programming, HTML programming, and QBasic programming? So many programming application in computer and website.
So purpose is different. So that the HTML is just a web script. We can say the script language where we design the page actually, that web page. Okay. So when you open any website, so that website page is designed inside using the HTML or this type of that is just a scripting language. Okay. But this these language like this C language, Python language, these are actually used as a backend language that perform the operations between that you are passing some data to the your website. Suppose you are filling some form for some that application job or something. So you are using some interface that is actually a
Okay.
web page. Okay, that is designed by the HTML language or some other scripting languages also there. But how that data is actually when you are storing that data into the form, when you clicking on the submit button, so
Yeah.
what program is running in the backend, so all your data will be stored inside the database in their server. So that operation is performed by some backend language. So backend language we use this that language like C, Python, Java, all these things. Okay.
Sir, one
So
more question.
hmm.
Mm, when a programming HTML finished, we have saved dot HTML. It it's necessary to use dot HTML to save the program. Extension name of the
Yeah,
QBasic also
extension.
used.
Yeah, yeah, extension is required because then only will we consider that which type of data that file contain actually. Okay, file extension is required to understand that what type of data is there in the file.
If I can use other word.
So that will not understand because what happening actually we are passing this C program to the compiler. So compiler actually will read some specific type of file to understand this. If you are not passing that the specific type of file, that will how that compiler will understand that what type of data is coming. So that
Oh,
dot C or dot py that is the just a uh, that actually filter things how what type of data is stored inside the file, and that compiler will that use select that file accordingly to execute.
or two more options you see in the computer, save as and save. When a program save and save as, so what's the difference between a save and save as?
So first time if you have suppose created any file. Okay.
Yeah.
So that file is not stored anywhere. So let me open any that 1 second. So 1 second. Okay, suppose I've opened this one type or this a markdown file. This is a markdown file where we write the document. So this file is just now opened. Okay, there is no. This is not stored at any place right now. First time open. So when we write any content like this is the sample file. This is sample file. So now the content is created. But first time, if we will click on the save, still it will ask the location as well as the name of the file. Or you can directly click on the save as. Okay, so let's click on the save button. You can see this pop-up is coming because this location and name of the file is not created yet. So because of that, it is asking to create these things. And let me just click on the save as button. Still, it is asking. Okay, the same thing. Once we will create the name of the file. Okay, suppose let me create the name or like test. Okay, and now this is the markdown file, and I have mentioned the location on desktop. If I have saved this, now this location and that name is created. In the next time, if I update this file, so like this is second line. Okay, now no need to save. Click on the save as button. Okay, so here that means save as means we want to give the name to the file. We want to assign the location of the file in our computer. But now we have done the process, so next time we can only click this save button. Now this is not asking again that pop up. Okay, but if you want to change the name and position again, so again you can click on the save as. It will ask again. Now you can see it is showing the name as well as it is showing the location or the same place desktop. Now you can change the name and position again for this file. Okay, so this is the option of save and save as. Okay, I hope this is clear.
One more, sir. It's a save in a primary memory, yes, secondary memory.
It is saved in the secondary memory. Okay.
Okay, sir.
Hmm.
Thank you, sir.
Yeah. So all these
Hello,
files which
sir.
we created, that all are saved in the secondary memory first. If we are running that file by the process or something, so that all that required data only will come under the RAM memory. So that will be fetched by the processor. Yes. Who is speaking? Rohit.
Hello, sir. Sir, it is necessary to take a laptop in the first term.
Yeah, because for C course, yeah, it is required for the programming assignments, and as well as this C course has the OPP exam, programming exam. So that is required because the OPP exam you can only give from the laptop, or if you can arrange the laptop, then that will also be okay. But laptop is required.
Okay. Thank you, sir.
Sir, OPP course is for Python student, no, not for the C programming student.
No, OPP is the exam, online proctor programming exam. Each programming type of course have this type of programming exam. Okay, so C is also a programming course that also have the two OPP exam in this course. Okay, so once you qualified with the qualifier exam and enter into that as a term student for this course, then you have to give the programming exam for this C course.
Okay, sir.
Hmm. Okay, Prem. Yeah, Prem Shukla.
Sir, am I audible?
Yes.
Hello.
Yeah. Yes, Prem Sahu. Go ahead.
Sir, as you type something on the notepad, like this is the sample file. So does it store like footprints?
Sorry, what I so can you repeat your question? It is saved
Uh,
as.
sir, like as you write the any text you write on the notepad. So does it
Hmm.
store footprint behind it, like before saving it, like a
Uh,
temporary log, yeah, text type storage?
you see, it is depend on the settings. What type of settings you have done in the that your editor. So this is just a editor. Okay, so where you can write a document like a Google Doc, and this is the typora, and we have the multiple type of editor documents. So logs are actually created because you can do undo or redo function for the each editor. Okay, so that undo and redo, how that is happening actually. So that is happening because all the data is stored in the editor. So let me open again and let's see this uh, file again. One second. Yeah, suppose if I type like this, hello, this is the text file like this. Okay, so now edit option, you can see undo and redo option is there. So let me just click on the undo. You can see this is removed. Last update operation is removed. But when we click on the redo, it is now come again. So how this data is removed and how this is come again? again, so some place it is stored actually, so that is actually logged. So some steps actually they maintain inside some log file. So what data operation we have done just now in the previous some steps, so that actually will be written back. So if you perform this undo multiple time, okay, so control z, okay, like this. Now already control v. So this is now different things. So redo is control y, sorry, control y. Hmm. Uh, Now I think this contain only some features. So undo. Now finish. So we have to go jump multiple times to reach at that position, that point. So now this is finished. Only I think this editor is contain only 3 4 steps of the save and undo operation. So but maybe another operations, another editor may contain more steps. So that is totally depends on that type of editor. So Google Doc actually stored uh, after each change. Okay, so that is depend on the editor features.
So like when we were saving the file, the log has been also been saved.
Sorry, log.
Also like when we are saving,
Hmm.
like we click on the save as, so the log are also being saved to the directory where we are saving along with
So
the file.
log, yes, yes. So that is also updated. So log is not always created because this is also depends on the type of editor. So log is mostly uh, comes under the IDE actually. When we write the write the applications, so when we runs the things. So for the simple text things, I think log is not created too much. Okay, so, some for basic steps, maybe some steps it actually contain the data. But yeah, when we store the data, when we save the data, it is actually stored inside the our storage device. So that instance actually stored.
Okay, thank you, sir.
Yeah, Chandan.
Sir, what is the SCT for OPP exam?
Yeah, SCT is system compatibility test, where the you have to join that some meeting link and you have to open the exam link. So that is simply a just a testing of your system, internet or camera for the programming exam. Okay, so you will get a idea that what type of environment you will get in the final OPP exam, or that your
Thank
system
you,
will
sir.
also
So,
test.
so what requirements are your system have to run the C programming?
Sorry, what?
What is the minimum benchmark for a system to run the C programming?
No, actually, this course is running on the browser. Okay, so if your computer is able to open the that browser that website perfectly, so that is the that is enough. But yeah, OPP exam, your camera should be working fine. Your internet connectivity should be very fine. Okay, and some your that Chrome version, that browser version should be also be updated. So that things are required. That is so that exam will be run on the browser, not any your device actually. uh, okay,
Okay,
hardware.
sir.
Hmm. Okay, so I'm opening the practice assignment first. After that we will take the that type of query. Okay, so otherwise this will not be complete. Okay, so let's open the practice assignment one by one and we'll discuss the answer. You can also just tell me what will be the correct solution for each. Okay. So now the first question is, which of the following statement best describe programming? Okay, so what is the meaning of programming according to you? Anyone want to speak?
Three option.
It is a programmed
Giving
instruction to the
instruction to
computer
a
to
computer.
do
Only
the
one
any
by one.
task.
Sorry, Ritu Raj, can you speak again?
Sir, it is a programmed instruction to the our system to follow in to do any task that we want to do.
Okay.
They give the instruction to the computer to can perform the certain arithmetic progression or anything else.
Okay. Yeah. So just read the each steps and just understand that it is correct or not. Okay.
Sir,
So
one
yes,
and two is correct, sir.
one and two both are correct.
Yes, sir.
Okay. It refers to how the data is organized and stored in the computer memory. Why this comes under the programming?
Sir,
No, sir,
programming
this
is a
is a wrong
basically,
answer, sir.
sir, programming is a process by which we give a task to our system, and the task is in a specific matter, and
Hmm.
they organize the data in computer memory.
No, organize the data is just a task of the operating system, but programming is just related to the process of the execution of
Instruction.
some specific task. So this is just a instructions process of instructions to the computer to perform a given a task. Okay, so this is just a operation of the operating system, how the memory will be organized, how the data will be stored, all these things will be managed by the operating system. So this is
Sir,
related
hello,
to the
sir.
hardware things. Yeah. Hmm.
Sir, it's a way to talk from computer.
uh, Talk to the computer is just a interface. Okay, but here programming is we can say that we are writing a sequence of steps to perform some task.
Yes, sir. In a means it's in a computer's language.
In the computer language, not the computer machine language. This is just a high level programming language that will interact to the that will convert into the machine level language. Then it will perform by the processor.
Yes, sir.
Okay, so using the programming language, we will just write a sequence of instructions to compute some task by the computer. Okay, so this is the process of this programming. It referred to the hardware that a computer can support. So this is also not relevant to the programming things. Okay, so here only option 2 is relevant for the programming terms. It refers to the process of instructing the computer to perform a given task. So that means we are telling to the computer how to perform the task. So that how to perform the task is just a sequence of steps. That is called as a program. Okay, so sequence of steps and plus data, we can say that that is actually a complete program. So option 2 is the correct for the first question. Which of the following is are not valid logical operator in the programming?
Sir,
If
assignment and
First
course.
and second.
Assignment and
sorry,
cost.
Assignment and code.
Assignment and
Assignment
cost.
and cost.
okay, okay, okay.
Sir, cost
Option third
operator,
and
sir.
fourth.
Okay, yeah, not valid. Yeah, not valid logical operator. So logical operator means
Sir,
The
basically takes the
gates.
values true or false and combines it, sir, like that.
So that comes under the that between the conditions things. Okay, suppose we have two condition and we want to test both condition are true or one condition is true, like this. Okay, so that connect the condition. So in this way, that is called as a logical operator. So and like end operation. So what is the end operation meaning is, suppose we have condition one, C1, C2, and we want to check that if both condition are true, then only we will do the task. Okay, suppose some task is given, and this task will only be performed if both condition are true. So how we can set this set this statement in the programming? So we have to use the AND symbol, and this is called as a AND operation. So that this is represent as a this C1 and C2 both conditions should be true, then only this task will be executed. Okay, if any one of the condition is true and another condition is false, so that overall result will be the false for this condition. Okay, so this type of condition statement where we get the result overall as a true or false boolean value. So the operator which is used for the with the condition like this, that operator is called as a logical operator. So we have this and operator, and we have the OR operator. So OR operator means we have condition 1 and condition 2, and we
Not.
have the OR signal single that operator in between. So here meaning is either condition 1 C1 is true or C2 is true. If any of the condition is true, that means overall result for this statement will be true. Okay, so if C1 condition is true, doesn't matter C2 is true or not, overall output will be true. If C2 is true and C1 is false, then still overall will be the true. If both are true, then overall will be the true. If both are false, then only the overall result will be false. So like this type of case, this OR operation is used. Okay, AND case, if any condition is false, output will be false. Okay, similarly not operation, so that not operation we have uh not and we have some condition like this. Okay, so suppose this condition is returning true, so that condition, that return output will be convert, okay, as a false by this not operation. So that actually used for the that connecting the conditional statement output, okay, and to so this is called as a logical operator. And here the AND is the logical operator, not is the logical operator, and assignment, this is another category of the operator. So assignment is just to assign a value to some variables. Okay, so this is the equal sign we have. So this is comes under the assign, and COS is not any operator. Okay, so this last two are the incorrect option. Okay, here we are asking the that means not valid. Okay, so because of that, assign and cos are the correct answer for this. So next is which of the following statement is generally true? So the memory unit is responsible for performing arithmetic operation in a computer. Uh,
No.
yeah,
No, sir.
memory is used for the storing the data
Save
only.
that.
No.
Yes, sir.
Yes, sir. C, sir,
No,
the
Option
right
C.
answer.
Sir, option C would be
is
the
the
right one.
option.
C. Okay,
The area responsible.
let's read the second
The
statement also.
LU
The
is responsible for
registers,
performing.
yeah, the registers are responsible for performing arithmetic operations in a computer.
No, sir.
No,
No,
sir.
they just temporarily
Registers,
save the.
yes, temporary store the data. This is also a category of memory. C, the ALU is responsible for the performing arithmetic operation. Yes. Okay, so
Yes, yes, sir.
arithmetic and logical unit. So that perform both type of operation, arithmetic as well as the logical. So this statement is correct. This is not correct. So next question is which of the following statement is true for a split memory architecture? Okay, so here split memory architecture we have seen that where the CPU is there, memory is connected, all these things. So the ALU fetch oblique write the data directly from the main memory. This is true.
No, sir. It will just first go to the register and then go to the
Yes,
LU.
yes. So this is not correct. We are asking the true statement. Okay. So the input data is fetched from the main memory and is temporarily stored in the registers to perform computations. So yeah, this is the correct
Yes.
statement. Okay.
Correct.
The result of the computation is temporarily stored in the registers until it is written to the main memory. Okay. So this is also correct.
Yes, that is correct.
Huh. So only option second and third is correct. So first is not correct. Because of that, this last option is also not correct. Okay, so which of the following statement is are correct? Again, this is the same about the memory. Hmm. So load refer.
Memory to register.
Okay,
True,
about
sir.
load and store. I have already mentioned this. Load refer to the process of moving the data from main memory to the registers. Is it correct?
To register.
Yes.
True.
Okay,
Yes, sir.
so this is the reverse thing, so it will not correct. Store refer to the process of moving the data from main memory to the registers. No. Okay.
No.
Registered.
No,
And
sir.
main
Fourth
memory.
one is correct.
yeah, fourth
Fourth
one.
one
Store
will
register for the process moving the data from registers to
register to
memory.
memory. Yes, sir.
Yeah. Yeah. So first and fourth is correct for this. Now, okay, next. The typical CPU keeps track of the position of the next instruction using.
Loop
Loop count.
counter.
Program counter. Program
No,
counter.
no, no.
Program count.
Program counter.
Loop counter, sir.
Loop counter is nothing. Loop counter is just a variable which we can use any register for that.
Okay, sir.
Okay, so that means how many times we want to repeat the iteration. So that actually managed by some registers value. Okay, we increment the register value and we check the condition that register value is reached at the some particular point or not,
Yeah,
and
Columbus.
based on that we can decide. But this program counter is a specific registers that contain the position of that next instruction that will execute. Okay, so this is the specific type of registers that purpose is
So,
only this.
so
Okay.
then what is the
So
descriptive
basically, so
program?
in the loop, it always goes back to the same loop, and in the register, it goes to a different program. I mean, in the program counter, it goes to a different register. Is that right?
No, no, no. Program counter is a registers that only the purpose of this registers is just to store the position of the next instruction in the memory.
Oh.
Okay. Loop
So then what does
counter.
the control unit do?
Sorry.
What does the control unit do?
So control is decided the operation of fetch, all these communication things. So control actually send the signal to the memory and pass to the that some data to the memory, and memory will. So who manage actually this communication things between the data that memory
Okay.
and register?
Okay,
So
got
that
it, sir.
managed by the control unit.
Got it.
Okay, and peripheral device is the totally out that physical device, or we can say that those who are interacting with the that computing device, like input device, output device, or any network device, all these things. So that are actually not the purpose here. What is the mention at the top? So this task is actually performed by the this is by only the program counter, and this condition is nothing. Okay, so condition is just a condition to check that will return it true or false only. So which of the following is true for the C programming language? So here, yeah, these are some that features type of points that I think I mentioned this in the notes. So which of the following is true for the C programming language? Okay, let's open the notes for this to understand which we have mentioned here that regarding the C programming language. Hmm. Okay, advantage. So in the last type, this characteristic, you can see this key characteristic of the C programming language, the procedural language. C follow a procedural programming paradigm focusing on the function and procedure. It's known for its structure and modular approach to code. So procedural means we will write a sequence of instruction, and that execution will happen in the top to down manner in this way, or we can write our code in the modular form, that in the function form, so that we can other language actually also use some oops concept that we can create that object and class. So that is called as a objected programming language. But C actually we cannot create this class and object things, so that not comes under that category. So C++ actually comes under that category, but C is generally a procedural programming language, that where we write the code by the using the function and procedure. So sequence of instruction like this. Okay, so we decide which function will call next, so based on that our control is actually execute. Portability, this feature, C code can be compiled and run on various platforms. Yeah, this is the portability, can be run in the different platforms, all these things. Yeah, C is the portable. This is actually used for the many operating system, the development. Okay, and that can be done in the different computer system also. Efficiency is also good for this programming language, because generally C actually comes under the called as a middle level language, not the high level language, middle level language. Other language like Java, Python, all called as a high level language. Why this C called as a middle level language? Because here we have the concept of pointers. So pointer can actually directly access the memory. So other language doesn't have this pointer concept. So because of that, we can that C is very closer to the hardware. So because of that, this comes under the middle level language. Okay, and most of the development things, embedded C like this, where we need actually the hardware control. So we use this C programming language and that embedded C program, embedded system, microcontroller language. Okay, so because of that. C provide low level memory access and efficient control over hardware. So this is the efficiency comes point. Strongly typed. C enforce strong data type. Yeah. So here data type. When we will learn the data types, all these things in the big three, you will understand that we have to define the data type for each data variables. Okay. So like Python, you no need to define the data. Okay. You can directly write a equal to 10, but here in C you cannot write a equal to C equal to 10. You have to define the type of A first. What type of data we will store inside the A. So that is because of that we generally say that that strong data typing. Then rich standard library, that contains lots of library that provide the direct predefined functions. And these are the some basic syntax, and this is some advantage of efficiency, portability, and vast community and resource compatibility. All these are some features, so you can just read this document regarding this C. And that then comes to the question. So here this imperative, I'm missing something, that word imperative programming language. But yeah, this, it is a statically typed language. Yes. So, huh. So here actually that is statically typed language, because if we suppose if we creating an array, like, okay, so array is a data structure. So if we fix the size of the array, then we can only use that size in our program. So because of that, this is static. Okay, so we cannot change the size of our array after declaration. So because of that, here we can, some data structure we have this static type of declaration. So because of that, this is called a statically typed language. Strongly typed language, this is not true. Strongly typed language. Okay, that is structure. Yeah, this is also not true structure. This is a procedural language. It demand a high capacity hardware. This is also not correct. Yeah,
Sir,
so no, yeah,
what,
structure is correct. Sorry, structure is correct.
sir, what does strongly typed mean, sir?
That also is true, no?
Hmm.
That
It
is
is a
also
strongly typed.
You just said about that strong type.
Yeah, so that type. It's
Sir, C program is weakly typed.
some confusion in the programming. 1 second. Mhm. Yeah, strongly
Yeah,
typed.
that
It was
it's strongly typed.
strong data
strong data
typing,
type.
meaning data types must
Yes,
actually
strongly
be
typed. Yeah.
declared. Okay, okay, yeah. So that I think should be correct. But I
So
think
the
it is.
imperative, the first one is incorrect because it is not an important programming language. It is one of the basic
No,
languages.
I'm just skipping this imperative meaning here right now.
It means it's
Sir,
very
I guess
important
in
for.
the
Sir,
lectures, the professor mentioned that it is a imperative programming language.
Yes, it is imperative, but right now I'm actually missing. Let me open that slide. Analysis, C writing. Yeah, this is imperative. Yes. I'll go to this specific commands. I think imperative meaning is just a, we have to tell that some definition is like this. Specify commands. So the another
Yeah.
type of language is non-imperative, where we have to tell to the computer how to compute the things. And so yeah, right now I'm not also clear, but something is like this, how we have to instruct that how to compute, but another language not instruct that how to compute things. They just generally only giving the commands, but doesn't matter how they are actually executing. Like this type of definition is there, but right now I'm not able to recall. So
Actually, in this, we have to break the steps in various steps.
sorry. Here, but weakly typed, easy type conversion. Yeah, this part actually I'll also check. Okay, so that some definition is different. Easy type conversion, yeah, type conversion is possible, but some definition is different for strongly typed where the type declaration is required. So okay, for this question I'll check this. Okay, and I'll update. Maybe next session I'll update. Okay, so right now
Sir,
I'm also not able to.
sir, imperative programming language means, I mean, all programming languages must be imperative, right?
No, no, no. Some definition is there for the imperative that we cannot say that all programming language is imperative. Okay. So I'll just discuss this in the maybe next session. Okay, on Tuesday. I'll clear this. Yeah, someone mic is actually creating some noise. Let me please check.
Sir,
Whose
I
mic
think
is?
it was about that we have to clarify in this.
Sorry, sorry. 1 second. Can you open your mic again? It is Ananya. Can you repeat? Open your mic again.
So, sir, I think it was related to that we have to clarify in this that this character is int or it is char. Maybe that's
No,
why.
imperative. You are saying that imperative?
Yes, sir.
No,
That
no. The meaning is not like this. Uh, but right now I am also not recall. Okay, we will discuss this in the detail. Okay, in the next Tuesday session. So I'll check
Okay,
that
sir.
all the points also that strongly typed. This is also now creating a confusion. So here the I'll check this. Let's move to the next. Okay, so suppose a CPU support only addition and subtraction in arithmetic. Yeah, this is and we have this sequence of what we are calculating a into b. Okay, so we want to compute this a into b. Let a and b is located at the memory location m0 and m1. We have these registers r0, r1, r2, and r3. Before available register, the result has to be stored at the memory location this. Now sequence of steps are given. Only one line is missing. Okay, so identify the appropriate instructions to fill in the blank at step 7. Okay, let's copy this and understand. Or this type of question you can directly just understand the procedure till step number 6. After that you can simply put option. Okay, otherwise you can also just directly come up to the conclusion after understanding the procedure but how we are solving in this. So copy this and 1 second, then we'll explain. So okay, so here we have the initial how many registers we have. R0 we have R0, and R1 we have, R2 we have, R3. Okay, so we have these three four registers total. Initially we have the first step. Okay, so instruction will execute top to down here one by one. Okay, if there is no control statement, so all instruction will execute one by one till 8. So now first step is assign 0 to R0. So now I have assigned to R0. Now R1 equal to M0. So this type of question you can take some value. Okay, so to understand better, because here there is no value. Uh, A is located at M0 and B is located at M1. Okay, so A is located here and B is located here, M1 position. Let's take some value. A I'm taking like small value you can take like 3, and B I'm taking like a 4. Okay, now that computation will you can easily calculate. So that means we want to calculate 3 into 4, or you can take more value to like 5. 3 into 5. So this our result should come 15. Okay, so 3 into 5 result should come 15. So now let's start. So R1 equal to assigning M0, so that means 3 value, and R2, that M1 value we will assign to R2, so that is 5 value. Now R3 is 0. Okay, so this is 0. This is the initialization in first 4 steps. After that, what we will do, R3 equal to R3 plus R2. So we are updating R3 registers. Okay, so what we are writing here, so R3 equal to R3 plus R2. So this is a instruction where we will compute this part and will store the result into this location. Okay, so what is the current value of R3? This is 0. This is 0. Okay, plus what is the current value of R2? This is 5. 0 plus 5. So now we will store this 0 plus 5 into R3. So the previous value will be updated by new value. Okay, in this step, line number 5. So what we have done basically, we have add R3 0 plus 5 value, so that R2 value. So this we can also indicate that this is a and this is a B representation. So now next step we are incrementing R0. Okay, so R0 by 1. So previous value was, so R0 equal to R0 plus 1. So that previous value was 0. 0 plus 1. Now that 0 plus 1 is 1. Now 1 to assign to the R0, that means updation. So that will be updated by 1. Okay, so now this is the step till sorry, step 6. Okay, so now this is the completion. So in this step, what we have done in first step, we have added the R2 value in R3 in the first step. Let's uh, move to the next step. So here 7 step is empty, and what we can assume, so how we can calculate this if we have only addition and subtraction operations. So what we can do, we can repeat this addition of 5. So that means this is A and this is B. So how we can write this, like 5 plus 5 plus 5. Okay, 3 times. So we will repeat the addition of B A times. We can see that. So this operation we can do, and initially to get the final result, we can start with 0 value, so that we can take some place and where we will start with 0 value, and after that we will perform this task. Okay, so we will get the final A into B result 15. So are we doing the same thing? So we have done one steps, and where we have add 0 plus 5. Okay, so 0 plus 5, that means R3. So that means we are planning to store the final result in R3, and we have added this R2 value one time, and we need to add this R2 value number of R1 times. Okay, so this R1 times. So based on that, we can decide the step number 7. So that means and this R0 we are using as a loop counter. Okay, so loop counter that thing. So this was the 0, and now it is incremented 1. So how many times we repeat this process? Total number of R1 times. So that means this R0 value should be compared to this R1 value. So here you can see in the each option, we have started with 0. Now, if R0 is less than R1, R0 is less than R1, yeah. So you can see these two options have this condition. Okay, R0 and R1 comparison, and remaining two, R0 is less than R2. So this is not relevant for this. Okay, now check from the first two option, go to step 3. Okay, so after performing this iteration, where we have to jump back, so that means we are performing addition in R3 step. Okay, so 0 plus 5. Next iteration, again this R2 value should be add one more time. Next iteration, again this R2 value should be add more time. So this instruction should be repeat again and again. So this is the fifth instruction, step number 5. Okay, so now that means if you see, go to step 3, go to step 5. So if we go to step 3, so R2 value will again reset to 5, and R3 will again reset to 0. This is not our goal, because we want to get the final overall sum in the R3. But if we jump to our third step, so third step will execute again, and fourth step will also execute again. So it will reset R3 to the 0. Okay, so that we cannot contain the final result by this. So we can only jump to the go to step number 5. So in this way, we will only perform this instruction, line number 5, then 6, then 7. Okay, 7, we are just thinking that this is the correct location. Let's just verify this. So if we take this second step as the correct answer, so R3 now repeating. Okay, after pointing this, so 1, this 1 is less than, what is the value of R1? 3. 1 is less than 3. Yes, true. Okay, go to step 5. So step 5 says that R3 equal to R3 plus R2 again. Okay, so let's remove this. Sorry. It's not working. Okay, so erase is not working right now. So let's I've just cut this. So R3 equal to R3 plus R2. Okay, now what is the previous updated value is 5. Okay, so 5 plus R2 value. Okay, so plus 5. Now 10. So this is 10 will be updated at this place. Next iteration. Okay. Now after that, next instruction is R0 equal to R0 plus 1. So it will become a 2. Okay. So now after that, we will check again. So 2 is less than 3. Yes. Again true. So just jump back to the same fifth number step. So R3 equal to R3 plus R2. So now R3 is now 10 and R2 is still 5, so plus 5. Now 15 will update at this place. Okay. So now again this R0 y plus y1. So that becoming 3 and now 3 is less than 3? No. This condition is now false.
False.
And if this condition is false, we will not go to the step number 5 again and we will move to the next step. So M2 equal to, this is the store operation. So we will store the final result R3, okay, this 15 into the M2 position. So 15 will store into the M2 position. So you can see second that option is fulfilling our computation purpose. Okay. So in this way, you can just understand, you can just take some small example. If variables name are given, some equation are given A into B, you can take some small value that you will get an idea that how the computation happen and are you getting the correct answer or not by the following the steps. And you can validate this. Okay, if you have understand in the one or two station, if you understand that how which value is getting the result, which value you are using as a loop, so then you can easily that conclude the which option can be correct or which option cannot be correct. So in this way you can just solve this type of question. Okay, now move to the next. Suppose two device, monitor and keyboard are mapped to the memory location 51 and 67. We have to write a program which takes an input value from the keyboard and display it into the monitor, identify the correct steps. Okay, so memory locations are defined here. So for monitor, memory location is 51 and keyboard memory location is 67. So that means devices will communicate to this memory locations for the data. Okay, so if we are passing some input from the keyboard, that will store inside the 67, and that data will be read from by the monitor. Okay, so okay, so let's read the option. What our purpose is take the input from the keyboard and display it into the monitor. Identify the correct step. Okay. So now read the value from the memory location 67 into the CPU register R. So that means what input we are providing by the keyboard that will store inside the 67 memory locations. Now that data will be read by the CPU and will be write into the 51 memory locations. Okay, and that memory 51 location is the monitor memory location. Okay, so that monitor will read that 51 location and will display. So this type of sequence will happen here. So value from the value of the memory location 67 into the CPU register R, write the value of register R into the memory location 51. Okay, so looking like this is the correct one. Read the value of memory location 51 into the CPU register R. So this is not correct. Okay, so 51 is a monitor location. Okay, so we will not read the 51 location into the CPU and write the value to the register. So the write operation will not be performed first. Okay, so this is also not correct. Write the value of the register. Right. Okay, so first we have to read the data. Okay, so and then we have to write the for the monitor location. So option 1 is correct for this. So next is a set of stored instructions used to direct your computer central processing unit is called as
Program.
Memory.
Program.
instruction. Set of stored instructions used to direct your computer central processing unit is called as
Sir, program.
program. Okay, so program is a set of instructions, not memory, not that network, not the logic. Okay. So next is which of the component is responsible for managing the flow of data between CPU and other components? We have mentioned this. We have discussed.
Yes, sir.
Control
Control unit.
Okay,
Control unit.
Yes, correct. Which of the following component is responsible for temporarily storing instructions and data during program execution?
With RAM.
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 RAM. Okay, correct. So program execution we are talking about. Okay, so because of this, RAM is there. Otherwise, instruction execution that happening and the instruction and data is required for that instruction that is stored inside the registers. Okay.
The floppy disk cache. What I mean,
Yeah, this
what is
floppy
floppy disk?
disk is the old type of memory, secondary memory
CD,
actually.
bro. CD.
Like a CD or DVD that actually used sometime before. Similar to this floppy disk is also used. That is actually tape type of memory. Okay,
So
so
RAM and register are same now. RAM
RAM,
and
no, no,
register.
RAM and registers are different. Okay, so RAM is the another type of memory. Registers are the memory, smallest memory for the CPU only. Okay, so that is the closest memory to the CPU, and that is the fastest memory. And if you see the document of that, which we have shared, one second. So there is a hierarchy of the memory, speed, and cost. All these things we can see this. Okay, so the CPU registers. This is the access time. You can see direction are given this side. Okay, so that means access time is increasing from this top to bottom manner. So CPU registers have the less access time from the CPU. Okay, so that registers. Then cache memory is the, that means CPU is the fastest memory that have the less access time. Capacity
So,
wise, yeah, this is increasing in this manner.
excuse me, sir.
Yes.
So where can I get this data, this text?
Can
Yeah,
you
this
share with us?
inside the supplementary content is available. Beakwise notes. Okay, inside the course page, you can see inside the supplementary content, we have this beakwise note summary. So all PDFs are there.
Okay, sir.
Yeah,
Okay.
I check, sir. Thank you.
So in this way, you can say is actually increased in this view. So this hard disk actually secondary memory have the largest capacity. CPU have the largest capacity to store the data, and the cost also actually cost increase in this manner. Okay, so cost increase in this manner, so that registers are the most expensive, cache memory is the less expensive compared to, and this is the least expensive. Okay, so cost is also increasing this. So this is the hierarchy of the memories, different type of memory in the computer.
So in which category RAM fall?
No, RAM is the one type of memory. No? So in this that comes in between. So you can see CPU is the closest memory. Suppose this is the CPU or this is the CPU point. Okay, now CPU communicate with this not CPU, this ALU we can say that because the registers also comes under the CPU. So ALU communicate with the registers data. Okay, and that registers data comes from the cache. So cache is also comes in between main memory and this registers. So cache only contains the repeated data which are coming continue again and again in the memory. So what happened? That control checks the things. If data is already available in the cache memory, then directly that we will get the data from cache memory if it is available. If it is not available in the cache memory, then only communication will happen from the main memory.
Okay.
Okay, so it increase the that computation time. So if any data is already available in the cache memory, so that will be fetched from here. And this all things are actually comes under the secondary memory. This side, okay, that store the data permanently. Okay, and this part actually is, we can see that this is comes under the volatile memory. If that only store the data which is currently executing. Okay, which of the following are the
Sir,
example of
sir, RAM is a different part of CPU or it is a part of a CPU.
RAM is not the part of CPU. CPU contains registers, arithmetic logical unit, or control unit, main, these three parts. After that, main memory comes out of the memory, that the CPU. Okay, but which is closer to the CPU for the data
Okay, okay.
access. So input device, following the example of input device in this. So input we have the key that this keyboard.
Webcam,
Webcam is
mouse,
also input device.
Webcam,
Mouse
Sir,
mouse,
and
webcam,
mic.
mic, mouse.
mouse, mic.
Speaker and printer is not a input device.
They are output device.
Yeah, this is actually some that you can just explore these things. Otherwise, rank the following in the order how much main memory actually they had. So you can explore this because all these are the practice questions. So because of that are included. We know that you cannot give this type of question answer in the exam. Okay, but this is released as a practice question, so you can explore that. So how much memory actually they that main memory means lang memory. Okay, so how much main memory actually they contains? So what is the order of to in order how much memory? So increasing identify the correct order.
the Apollo has, I think, 32 KB memory.
Approx like some have some KB that some have MB like. So this is the older one that computer systems that contain less memory. That less memory. So rank the following in the order of how much main memory they had. And where the correct order. So it is not mentioned that it is in increasing order or decreasing order. Okay. Yeah, I'll also check this. Uh, okay, so you can just explore this how much memory they actually used as the RAM memory. Uh, all these type of that um, computer system which is used inside the Apollo, IBM mainframe, or Apple iPhone. So Apple iPhone, this is the largest one. Okay, so iPhone is the largest. All are the previous older devices actually. Arduino, this is a microcontroller. This is also contain the memory in the like some MB, 12 MB like this. But this is third is the largest one. So I think if we are writing in that increasing order, so that should be the correct. But I think it is not mentioned here. Okay, and this is also a also computer things. Which of the following are computationally equivalent in theory? So here the processor all processor can compute the all arithmetic operation and logical operations. Okay, so that is asking here that maybe that storage capacity is different, number of instruction execution may be different, but all are actually capable to perform the arithmetical and logical operation that is generally processor perform. Okay, so the definition is two processor are considered computationally equivalent. If anyone then can be performed using one, another can also be performed. Okay, or vice versa. So here all are actually equally computationally equivalent because all are capable to perform the all that computation processor. Okay, but maybe the capacity is maybe different. So here all of the above answer is correct for this one. So this is the question. So now you have to practice this type of question more. So graded assignment have this type of some questions. So only the way to solve this type of question is just take note down each storage point and uh, compute each step one by one from the top to down and update the value like this. What I have done in this example. So I have note down all the registers and I have updated the value. After that, each steps how we are updating the value. Okay, so in the each instruction, if we are writing like this, okay, you can see this instruction. So what is the meaning of this? This side is actually a expression or maybe sometimes value like this. So r3 equal to like 5. So always consider that this is right side of the equal sign is just a data. Okay, and this is a location. Okay, so that data will always stored at this location. Okay, so suppose if we write like this, so r2 equal to r1. So don't confuse in this statement. That means what data is available at this location, that data will stored at this location. Okay, so just read the data or the compute the data on the right side and assign the data to the left side location. So that is the happening in the each instruction. So here R3, what is the data of R3, what is the data of R2, the add this data and assign to this R3 location. So assigning means if previous any value is already there at this location, that will be updated by the new value. Okay, so just note down this data updation or data tracing after each steps. Then you will get a complete final answer. Do not just try to random things. Okay, so just go to step by steps for this type of
So,
question.
so the M in that is the main memory, is it?
M is mentioned here, that is a main memory, and these are the registers. So data is coming from the main memory first into the registers, and then computation is happening, and finally we are storing the result into the main memory
Yeah,
in
goes back
eighth
to the
step.
main memory.
Yes. So this is the generally computation happen, but we are not giving any very strict things in this type of question. So this is giving just a idea of the computation, how the computation happen, how the steps are, sequence of steps are written to solve any problem. Okay, so this is not just a standard way to write this type of questions. You will not get too much questions on the internet resource of this type, because this is just a giving the idea of the computations in the terms of memory models. Okay, but that will comes for the in the programming from the big three, where you will use the that steps in the C language. So how you can write all the steps in the C language, and then you have to write the C instructions, so C program. So same type of computation you have to write with the help of C syntax. Okay, so just practice on this question. So some graded assignment questions are also there. Uh, yes, qualify. Okay, so let's. Yeah, that one question that imperative or that features of the C that I'll check and update in the next session. Okay, on Tuesday. So you can see there are many question is there. So this is just a expression type of question. How many primitive operations? So primitive operations are what? That this multiplication, plus, minus, division. So what are the operator we are using in this expression? So that actually we need to count here, okay, to solve this. So this expression is given if we have only this plus and into operations. So how we can perform? So just expand this expression in the terms of this plus and into operation, and check how many operations you need to require minimum. And you can see this is the similar type of question. So sequence of steps are given to sum of first n number. So just take some example, and here no need to take any example, because if you take n equal to 5, so this sequence of steps should give the answer for 1 plus 2 plus 3 plus 4 plus 5, like this. Okay, so just go through step by step and just apply the process. Okay, and yeah, there is one this type of question. Okay, this is simple. Here there is no loop or anything. Okay, so you can just take the variable. So here we are not explaining any memory things or any things. We are taking simple variables. Okay, P is the some location where we are storing 25. Q is one location where we are storing 10. But after following this sequence of steps, what value you are getting inside the P, Q, and R final value. So just note down P, Q, and R, and assign the value and update the value by after each operation, and check finally what your value you are getting in the each locations. So this is also very similar. This is also a simple steps, so no any loops or things. So loop and someone is asked in the previously. So what is loop and what is the conditional statement? So loop and conditional statement means, so sometimes what happen at the time of execution happen. Okay, so I'm taking very small example. If we have one value n, okay, now n may be anything, any number. Now we want to check that this n is a even number or odd number. We want to print the result. This n is a even or odd. So here two answer are possible. So in this way, our program will print either a even answer or odd answer. So what we will do when we will write the program, we will use some conditional statement to check this number is even or not. So what condition statement we can write like this? If n, we will just divide by this 2 and check the remainder. Okay, So suppose if we check the reminder like this, so in C we generally use this percentile symbol to return the reminder. This is the one operator that return the reminder directly. So if this reminder is equal to 0, so double equal to means we are comparing the left and right side value. So this is the conditional statement. So if both side the value are same, that this statement will return it true. Okay, so now we will write a two area. So this is one block, else is a second block. Okay, so this if this condition become true, then this block first block will execute. Okay, so like we can write like this, statement 1, statement 1, and this is statement 2. Okay, so this statement may be just a printing to display something. Okay, so if this n percentile 2 is become equal to 0, so that we will run only this statement 1 will execute, this part will not run. But if this is not equal to true, then first part will not run, second part will run. So based on the conditional statement, we will decide our flow of the execution. Okay, so that is actually called as a conditional statement. So based on the condition, we will decide which part of the code should we execute. Okay, so that is called as a conditional statement. So this type of statement we need to solve many problems. So okay, so suppose we are checking that the number is prime or not. So that is comes for the to solve the any type of problems, that is very common. So that programming, each programming language provide this type of conditional statement. Okay, and what is loop? Suppose we want to find out the sum of first n number, and we have any number like n equal to 5. We want to find out the sum of 1 plus 2 plus 3 plus 4 plus 5. Okay, so this is very fine. If we are asked that what is the sum of first 5 numbers, so you can simply write like r0 equal to 0, and after that r0 you can simply write like this instruction: r0 equal to r0 plus 1, then r0 equal to r0 plus 2, r0 equal to r0 plus 3, and r0 equal to r0 plus 4, r0 equal to r0 plus 5. Okay, now you have written this sequence of steps. So r0 was 0, after that you have add 1, then 2, then 3, then 4, then 5. You have done these things and you will get a final answer in the finally. Okay, so you will get a result. Here this is the fixed value 5 we are taking, so you can write this type of code for that. Okay, here 5 times you have repeat the instructions. But what happen if we are passing n equal to 100? Okay, so that means we are repeating the same type of instruction, only this value are actually changing, or it is incrementing one by one in the each steps. And now we are getting n equal to 100, so you have to write this step 100 times. So maybe you can write, but if suppose if it is given 1000, then you have to write this line 1000 times. This is not possible and not correct. Okay, not the correct way to write the program. So what we can do, every programming language provide a loop statement. That means we can repeat a loop, okay, multiple times. We can decide how many times we want to repeat, and in the each loop we can update some value and we can perform the things. So in C language what happened, there is a statement like for loop, and we take some initial value, like we take variable I equal to 0, and we take the condition I is less than equal to n, or we take the last step I incremented. Okay, so I plus plus, and inside this loop we will only write r0 equal to r0 plus I. Okay, and we will set r0 equal to 0 initially. So now this is the one statement, and this is the loop syntax. And this loop syntax said that I variable we are taking here, that start from 0, I equal to 0. Okay, now this is the initialization of the first time I. After that we will check this condition. This is the conditional statement. If I is less than equal to n, now n you can take any number. Okay, if you take n equal to 5, just replace this with 5. Okay, so now this is the conditional statement. We will check I is equal to 0, so 0 is less than equal to 5. Yes. Okay, if this condition is true, this block, okay, this is the block for this loop, and this you will, that control will enter into the block inside the block, and this operation will perform. So now r0 was 0 equal to r0 plus I. Okay, so now what is the value of I? That will be represented 0. And what was the value of r0? That is 0. Okay, so now that we are getting this 0 again, but this is the next step for the loop. After execution of this body, this block, now this instruction will execute. This is a increment operation. This will increment the I value by 1. Okay, now then next step I will become a 1. Okay, so now again condition we will check. So then now 1 is less than equal to 5. Yes. Then again r0 equal to r0 plus I. So I means 1. Okay, so 1 plus 0. So now it will become a 1, and 1 will be stored into r0. So now again incrementing, then I will become a 2, and again 2 is less than 5. Yes, again just add operation. Okay, so now this operation is repeating this number of times. Okay, so we have set the condition. Every time we are incrementing I by 1 and checking the condition, and we are using this I value in the addition. So like this, at this place we have updated this I as a variable I, and I is now incrementing 1 by 1 by this loop. Okay, by this expression. So only these three steps we have written in the code, but you can perform this repetition based on this n value. If you set this n equal to 100, then this loop will run 100 times. This instruction will repeat, execution happen 100 times. Okay, if you change this n equal to 1000, then still it will work. Okay, this instruction will execute 1000 times. Okay, now we are not changing any things in the code. Okay, only this value we have taken as a variable. Now this value is changed. Based on that, this number of repetition is will be changed. So this is actually a loop, called as a loop. Okay, how we are deciding that how many times you want to repeat the execution of the instruction again and again by this loop, instead of writing the instruction that number of times. So that any programming language provide this type of basic features, that loop, conditional statement, or we have the different. This is the one type of loop. For loop, while loop is also there. Okay, and some switch statement is also there. Function, all these things we will discuss in the detail from week 3. But this is the things loop. We want to repeat the same type of steps again and again. So that's called as a loop. Okay, so I hope this loop and conditional statements are clear. We will discuss these things in the programming in week 4 in the details. Okay, and we will also solve the assignments. Okay, any query in this? Yeah, Govinda. Okay, Govinda Nora. Okay, so now just practice on solve all the graded assignment. If you have any doubt, okay, then you can also discuss in the Tuesday session. So Tuesday we will start the session in the from the next week 6 to 8. So
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
If you no more doubt, then we can close the session. Okay, thanks everyone.
Okay, sir. Thank you, sir.
Okay,
Thank
sir.
you, sir. Thank you,
Thank
sir.
you, sir. Bye.
Thank you, sir.